Good morning, everyone, and welcome to our Wednesday seminar. Geoscience Australia values the lands, water and sky as we work to deepen a shared understanding of country and earth. We respect First Nations peoples and their enduring connection, contribution and obligations to country. Reflecting on our shared history, we are committed to listen and learn. Today, I am joining you from the country of the Ngunnawal and Ngambri people and acknowledge their elders past and present. Good morning, everyone, and welcome to our Wednesday seminar. My name is Marie Wilson, and I'm the Chief of Place and Communities Division here at Geoscience Australia. Our seminar today is titled Mapping Australia's Future, How the Digital Atlas of Australia is Transforming Place-Based Decision-Making, and I'm delighted to introduce you to the leaders from our key partner agencies of the Digital Atlas of Australia. So our speakers today are Lisa Bush, who is the head of Geoscience Australia's National Location Information Branch, which is leading efforts to enhance our nation's geospatial capabilities and key government projects like the Digital Atlas of Australia. Scott Clowder is Manager of the Data Capability and Services team at the Department of Industry, Science and Resources. That team comprises geospatial and data analysts whose function is to provide data visualization and analysis, geocoding and mapping services across the different themes at the department. Michael Chadbourne is the Assistant Director of Geospatial Services at the Australian Bureau of Statistics. He leads the ABS Digital Atlas Work Program, which focuses on delivering geographic web services and user-friendly applications for public use. And our fourth speaker is Tomm Robinson, who is a leader in business intelligence at the Department of Social Services. Tomm is currently overseeing the provisioning of place-based data onto platforms such as the Digital Atlas of Australia and building capability within DSS to enable quality use and sharing of place-based data stories and insights. So a huge thanks to me for our three guest speakers for making the time to share their team's journey with the Digital Atlas. Today we'll be using the Q&A box at the top of your screen as we go through. So as we go through the presentations, please pop your questions in there. We will have some time at the end for our presenters to answer any questions you have. So please join me in welcoming Lisa Bush, who will kick off today's presentation. Over to you, Lisa.
Thanks, Marie. Look, our world is becoming increasingly data-driven, and the data that we collect and use across government is diverse, dynamic and valuable, not just to those of us in government, but to all Australians. Yet our challenge is to ensure that our data is more findable, accessible, interoperable and reusable, so that decision makers can access and use data and extract meaningful insights efficiently and effectively. A common factor across most data is that it can be related and be allocated a location in both time and place. And it is this connecting thread that enables us to link and combine seemingly disparate data sets, revealing patterns and insights. But to bring this data together and extract those location-based insights, we need robust geospatial infrastructure. At Geoscience Australia, we have collaborated with government partners to deliver this capability for the nation. Earlier this year, many of you know we launched the Digital Atlas of Australia, the government's new geospatial platform that is enhancing and integrating Australia's government geospatial infrastructure. And today, some of our government partners, our early adopters, will share how they are using the Digital Atlas. You will see how they're making their data easier to find, access, use, and importantly, reuse, and also get an insight into some of the innovative interactive maps and tools they're creating collaboratively to unlock place-based insights to inform their policy, program, and service delivery. But before I go any further, I will play a short video that will give you a little bit of an insight into the Digital Atlas.
To build a brighter future for Australia, we need access to data that's timely, reliable, and relevant to make better informed decisions. But with the increasing amount of data available, finding and using it can be challenging, as it often sits in disconnected silos. This is changing with the Digital Atlas of Australia, an interactive, secure and easy to use online platform that brings together, curates and connects trusted national datasets. Powered by a digital ecosystem, it seamlessly integrates data across borders and systems on Australia's geography, people, economy and the environment, using location as the connecting thread. Explore data by theme, like transport, geology and soils, land use and more. Analyse data on demand using interactive maps and tools. And visualise data, pinpoint areas of interest, upload data and share information and insights at the click of a button. From optimising planning and investment using infrastructure and population data, to identifying business opportunities with the latest industry and workforce data, and revolutionising agricultural practices, analysing data on soil and geology, water bodies and land use. The Digital Atlas is unlocking the power of smarter, place-based decisions. Explore the Digital Atlas of Australia today at digital.atlas.gov.au.
So by way of background, the Digital Atlas is an Australian government initiative which is being led by Geoscience Australia. It was introduced in the 2021 budget in response to the need for timely and relevant geospatially enabled data to address the diverse challenges our nation faces. Underpinning the Digital Atlas is integrated geospatial infrastructure, a digital ecosystem that enables us to connect and share data from and into a range of different systems, portals and technologies. The Digital Atlas has 3 information domains, as you can see on the screen in front of you. On your far left, you'll see the source, and that's really our sandbox. That's where we're playing with data and applications to make sure that they function as best as they possibly can as a web service before we make them live either in the Digital Atlas for Government or Digital Atlas for Everyone. The second environment is Digital Atlas for Government, where you are an authenticated user, and it allows us to share information with select government users, and we can also, inclusive of that is sharing classified information. We can also access a full suite of GIS tools, and importantly, we can collaborate in real time across a range of boundaries, whether that's within our own department, across multiple departments, or across multiple levels of government. And on the right, you can see the Digital Atlas for Everyone, and that is available, as it says, to everyone, to public, with a whole range of data and tools and services sitting in the Digital Atlas in a public-facing Digital Atlas for Everyone. We have a range of data suppliers and users from across government sectors integrating their data into the Digital Atlas or using it for location-based decision-making. The Digital Atlas infrastructure is enabling both suppliers and users to connect their systems to the Digital Atlas. As an example, data is connected from the Australian Bureau of Statistics into the Digital Atlas. The Digital Atlas then connects it into the Australian Climate Service environment, which pushes information into Home Affairs environment to support the National Emergency Management Agency. The power of this is that data from the Australian Bureau of Statistics is maintained by the ABS as the custodians at all times. So if any changes occur, that they are simultaneously updated across the network. I guess the key point really here is there is no single bucket, and there will never be a single bucket for data. It is about connecting, integrating data through an integrated geospatial infrastructure. So you have access to the very latest, most up-to-date geospatial information available. And talking about data sets, at the moment we have 173 data sets sitting in the Digital Atlas. You'll see that's particularly high for population distribution and geology and soils. And that is because we've been able to uplift some geology and soils data from Geoscience Australia, and also the Australian Bureau of Statistics has been our key partner from the beginning of this journey and has been able to geospatially uplift a range of data into web services as part of this project. This data has been curated through Foundation Spatial Data Framework in accordance with best practice as articulated by the United Nations Global Geospatial Information Management, but we'll look to be able to build that across different themes to make sure it is the most accessible it possibly can be for our users moving forward. Now I'd like, so in short, Digital Atlas and the technology, data and capabilities that we're making available to meet the need of a huge range of many diverse users. Our government partners presenting today are going to tell you about how they're using the Digital Atlas, either as a supplier of data, as a user of the Digital Atlas, or as both a supplier and a user. These presentations are just a glimpse of what is possible by the Digital Atlas, and I'm now going to hand over to Scott Clowder, from the Department of Industry, Science and Resources, so that he can tell you how DISR is using the Digital Atlas. So I'll stop sharing and pass over to you, Scott.
Thanks very much, Lisa. I'm Scott Clowder from the Department of Industry, Science and Resources, and I hope that you can all see these slides. So as you can tell by our long acronym, oh, excellent, there's some thumbs up, that's great. As you can tell by our long acronym, we have got a very wide theme of subjects that we deal with. You can understand that there are so many different streams of work happening in our large department that employs over 3,000 people. So my job in the Analysis and Insights division is to assist a lot of those employees with their various endeavours, which include ensuring that they can get the best data and understand data and gain insights from that data in order to make trusted evidence-based policy recommendations. So the way that Digital Atlas is helping to contribute to that and transform our work really is that it's an easy to use geospatial and data discovery platform, and this sort of represents a new capability for our agency. The access to the Digital Atlas has improved our discovery of high value data, enabled us to maximize the value of the data that we've got and use it in new ways. So that means that we're really, and look, we're at the start of quite a long journey in this, I think, but it's helping us to see where we can go in terms of embedding data into policy development, making informed decisions, and helping our colleagues to do that, and helping our colleagues understand how vital place-based data actually is when they're looking at policy. And sometimes the easiest way to do that is visually. It is on a map, and as soon as our colleagues see that and interact with this capability, then it gives them a whole new appreciation for the topics that they are subject matter experts in. So I'll give you 3 examples. The first one is the Australian Space Agency. It's pretty cool. We've got space people just down the corridor from us in this, urban office in Canberra. And the Space Agency got involved because, as you'll see from that picture, interesting things occurred in the Snowy Mountains a couple of years back. Space junk, or space debris, as it is probably officially called, descended to Earth and ended up in the middle of a paddock in the Snowies. And this is representative of the fact that there is space debris floating around, and sometimes it does in fact end up on Earth, and so we need to be able to track it. So following the discovery and the recovery of this, and this is from SpaceX, this debris, the agency developed a pilot monitoring tool to assess space objects that are potentially re-entering the Earth's atmosphere. And so I'll give you a little demo of what you can see here, which is the pilot atlas. You can see there's many layers. I'll just stop it there. You can see there's many layers which can be added to the atlas according to how you'd like to visualize things. And you can see here we've zeroed in on a particular item, and you've got metadata about that item. You can then zoom in and look at the area around the item. And so here we can now combine data, and that's the great use in combining data, not reinventing or collecting new data, but combining existing publicly available data. For instance, about all the schools in the area, or all the hospitals, or all the public places. So we can look now and we can overlay these different types of structures, and then we can actually decide to export that data. And then once we've exported that data, we will see that we've got a PDF. And in this case, there's a little map or a little, schematic showing where that potential object fall is. And then the list there is a list of the data that was previously visualized. That's all the schools that are in that particular area. So that's the Space Agency. And moving from space onto science, Questacon. Those of us who are based in Canberra will know it. It's the National Science Museum for, children, educating people. You will have known it if you've been on a school trip to Canberra. You've probably been to Questacon. It's a great place full of really talented and dedicated science educators. But the thing with Questacon is it does not just deliver at that particular location in Canberra. It's a specialist division of DISR, but they actually deliver a suite of professional learning programs to educators across Australia. So one of their key focuses is to target schools with underrepresented audiences and encourage them to consider future STEM careers. And that ties in with all the work that we're doing in the department, actually, about understanding the trajectory of STEM pathways, both for female students and for students from different diversity groups, and seeing where their studies and their potential careers take them. So we know that that's a really important aspect for us, and Questacon knew that, and so just being able to sort out where they're going and which schools they're visiting, it sounds really simple, and in a sense it is, but the simplicity of some of this data is what actually sells it. So you'll see here, and I'll just stop the video for a minute. You can see here that we've got points on this map. That's all the schools in Australia. There's around 11,000 of them. But we've got rich information about each school's enrolments. That's from ACARA. There's big, again, national publicly available data sets that include data about how many people are in the school and who those people are. So you'll notice that the different color dots depict whether or not the school has actually been visited. Not too many schools out of the 11,000 have been, but that means that they need to target their resources really efficiently. So that's why we include those filters in the map that enable Questacon to sort of analyze the data set, and they can find schools that meet their criteria. For example, they can use those filters on the right hand side to find schools that are in remote areas or that are in areas of high disadvantage, which is really important, with a high number of female students, with a high percentage of Indigenous students. And they can target that and see where there are clusters of schools that have got those characteristics. And so then that will obviously make it much more efficient when they're planning their visits to be able to see where else is around them that would actually fit the criteria. Also, you can see there CED, that stands for electoral divisions. So again, that's data that's already been collected. We don't need to recollect that. We can just use that as a layer. And as you can see, we've picked a particular electoral division and been able to focus right in on that electoral division. And again, we can export that for use in other formats. The final example that I would like to give you is about enhancing First Nations data. We're currently creating interactive maps in the Digital Atlas to provide our staff members with ideas and to provide them with just understanding and access to First Nations data insights at a regional level. And again, this is not about collecting data from people that is new. This is about using what is already publicly available. So you'll see here that we've got a database of languages from Ostlang, and that allows users to use the near me function of the map and see which different languages are spoken or indeed have been spoken in the area that they pick. The broader focus of this project, and as you can see here, the different Indigenous areas, native title, and again, other publicly available data sets. But the broader aim of this project is that our staff members can then understand the different lenses with which to view their existing data and ways to try and understand Indigenous participation, or indeed lack of Indigenous participation, in the different government assistance programs that we have and in different projects that we do. So it's basically just trying to showcase what is already there. And so I think one of the big advantages with this, the Digital Atlas of Australia product, is that being able to use existing data makes us realize that we don't have to reinvent the wheel here, and actually being able to visualize data in different ways and combine it with other data sets can actually bring real value, depending on who your audience is. So the geospatial team is trying to lead the uptake of the digital atlas across DISR, and our agency and our Questacon colleagues are now able to maintain and enhance those products that we've shown today. As I say, it's the start of a journey, and so we can share that across the agency and also within government, and then we can work, collaboratively on different cross-cutting issues and priorities. So those were just 3 examples, and I'm now going to hand you over to Michael Chadbourne, who's the Assistant Director of Geospatial Services at the Australian Bureau of Statistics. Thank you.
Good morning, everyone. So today I'll be talking about a user-friendly application the ABS has delivered to the Digital Atlas of Australia, and this explores indicators of socioeconomic disadvantage and the contributing indicator variables derived from 2021 census data. So for those of you who love exploring demographics, this is definitely for you. So the Digital Atlas has made ABS geospatial data more accessible and easier to use. Through the project, the ABS has built a platform that enables us to feed our data through a pipeline to the Digital Atlas. The ABS has delivered over 65 web services and over 1,000 data items, including statistics on Australia's population, health and disability, economy and industry, and land and environment. The application I'll be showing you today is available right now for you to use. So get into it and boost our usage stats. The data within the application comes from a product called SEPA, or Socioeconomic Indexes for Areas. SEPA is a product developed by the ABS that ranks areas in Australia according to relative socioeconomic advantage and disadvantage. The indexes are based on information from the 5-yearly census. So SEPA consists of 4 indexes. The Index of Relative Socioeconomic Disadvantage, RSD, which is the one used in this app, the Index of Relative Socioeconomic Advantage and Disadvantage, the Index of Education and Occupation, and the Index of Economic Resources. The data used in this app includes the overall score of RSD represented as a quintile, and also includes the standardized value of RSD indicator variables for each SA1 across Australia. On the screen, you can see an image of what the raw data looks like when downloaded directly from the ABS website, and that's an Excel spreadsheet. So this raw data was a table that was converted into accessible geospatial web service, available for anyone to use in the Digital Atlas, and was the primary data source. So in terms of planning and design, so the planning stage was essential for creating the user-friendly application. It was important to define the purpose early on, which was to provide a deeper understanding of local area disadvantage and its drivers. The target audience included those who wanted a better understanding of community needs to design targeted policy interventions and services. The audience did not necessarily need to be a geospatial specialist to understand and use the app, so it's available for everyone to use. The data to be used in the app was specified and governance procedures were set out as early as possible. We drafted several options simply by using pen and paper before opening Experience Builder. So the planning stage gave us a good understanding of the type of functionality we required for the app. For example, we knew we wanted a splash screen window to help explain the complex nature of the data, and we wanted 2 main map pages to toggle between the same map extent. And there's a lot of great Esri documentation out there for those looking at creating their own apps. So I'd recommend having a look at the Esri ArcGIS Experience Builder Gallery to gain some inspiration. So testing and approvals. In the testing and approvals stage, we applied organisational branding, and we were guided by organisational interactive mapping standards. When a first draft was ready in Experience Builder, we were able to provide executive staff with viewer access to the application within a restricted access group so they could provide their feedback. By providing viewer access, those providing approval could see exactly what the app will look like and how it works interactively before it was published to the public. Once approved, the data was shared publicly through to the Digital Atlas. So in terms of where you can find the app, just go to the Digital Atlas website at digital.atlas.gov.au and click on this link here. So this is the home page for the app. The main map displays Statistical Area Level 1 or SA1 boundaries derived from the Australian Statistical Geography Standard or ASGS, which is a social geography developed to reflect the location of people and communities and used for the release and analysis of statistics and other data. SA1s are a small geography with an average population of about 400 people. The SA1s include an IRSD quintile score from 1, most disadvantaged in dark purple, to 5, least disadvantaged in the lighter shade of purple. The user can click on the map, and on the right-hand side, you can see the IRSD indicator variables by SA1 are dynamically displayed, allowing them to explore which components are influencing the overall score. The lower the number for the indicator, the higher the disadvantage. This indicator profile was created with a text widget, allowing the addition of a dynamic text from the selected SA1 data. If you were to look at two different areas with the same CEPA IRSD score, you might expect these areas to show similar socioeconomic characteristics. However, the indicator data is what really tells the story about which components contribute to the overall CEPA IRSD score. Now I'm going to focus on some Adelaide examples here, so apologies to those that don't know Adelaide, but it's a good opportunity to promote it. So, for example, in an SA1 in Playford, near Manopara, north of Adelaide, very few people were reported to have low English proficiency or no formal education. Whereas an SA1 with a similar IRSD score near Port Adelaide Enfield, low English proficiency and lower formal education was reported to be more prevalent. The secondary map page in the app provides a deeper understanding of the overall individual indicators. A map layers widget was used to allow the user to select and explore each individual indicator in more detail. The legend shows the IRSD indicator from 1, relatively high proportion in dark red, to 5, relatively low proportion in light yellow. The map shows the indicator of low English proficiency, which is in relatively high proportion in areas north of Adelaide. The user can select different indicators on the right and the map will update. Another feature of this application is you can set filters for a range of indicators. In this example, I've filtered areas where low English proficiency, no formal education, and unemployment are all in relatively high proportion. This functionality allows users to explore the data in a specific and customizable way. While these areas may be identified as relatively disadvantaged for the selected indicators, it does not mean that all individuals within that area are disadvantaged. Let's take a look at another specific example of how this new app in the Digital Atlas can be used. We're going to take a look at High Marsh Brompton, an inner suburb of Adelaide. On the surface, the CEPA disadvantaged percentile of 42 doesn't really tell us a lot about the area. It's neither the most disadvantaged nor the least disadvantaged community in Australia. It's somewhere near the middle. Using the CEPA app on the Digital Atlas, we can explore this area of Adelaide at a more granular level, and it tells a very different story. As you can see by the very dark and very light regions, High Marsh Brompton has areas that are most disadvantaged and other areas that are least disadvantaged. This is a very diverse area in terms of its population's wealth and needs. It's important for decision making and planning of services that this variation is understood. Using the CEPA app indicator page, we can dig deeper to understand the indicators in the disadvantage index. We can select different indicators that tell different stories about the communities within High Marsh Brompton. At this level of detail, you can see where overcrowding is high, and for High Marsh Brompton, this is actually slightly different to the picture of low income. You can also see where there are concentrations of people with a need for assistance, another indicator in the CEPA index. The level of detail in this Digital Atlas map enables a better understanding of community needs and the design of targeted policy interventions and services. Thank you to Geoscience Australia and the Digital Atlas of Australia to help bring to life ABS data and providing users with new and valuable ways to understand Australian communities and demographics. To hear more about the latest ABS geospatial data and products, please sign up for the ABS Geospatial Notification Service. And that's it from me. I'll now hand over to Tomm Robinson, Acting Director of Data Visualisation and Reporting Section at the Department of Social Services. Thank you.
Thank you, Michael. Very good app. I actually used it the other week for some of my rental applications I was doing, which was really handy. But on to DSS. All right. So DSS, there's a broad range of programs and initiatives that we manage, and through this we generate a huge amount of valuable administrative data about these programs, their goals and objectives, as well as the people who receive support through them. We use this data with other external data that we bring in to help inform decisions that we're making and ensure that we're making valuable and useful policy decisions. Recently, there's been a bit of a need to increase our capability to spatially analyze data to assess the need for and impact of those DSS programs and services in specific areas in Australia. This is where the Digital Atlas comes in. So this platform is very useful for us because it acts as a collaboration platform, which enables us to have conversation between government and community. It's easy to access, there's a low barrier to entry, and we're confident that there's mature and reliable data sets that have their appropriate metadata and they're maintained and updated in a reasonable time frame. Lots of opportunities here to support those conversations, be it between local government and federal government or state government or government and community at any level, to help identify and understand the different priorities impacting Australians in different parts of Australia. It also helps with transparency around the different government services being delivered and why they're being delivered, so we can have conversations about them to make sure we're doing the best ones possible. Okay, first steps. So we started with income support. Income support data is very easy to spatially set up. It's all every program is known, all the individuals are known and identified, and it's all recorded at an address level. So I've got that very detailed information. It's also publicly available on data.gov.au. So it was just a matter of lifting that data, moving it to a new platform, and then deciding what stories to tell with it. In doing this, we've worked with both ABS and Geoscience Australia, who have helped provide technical capability to develop the apps, while we focused on the data and the story that we're trying to tell. To date, on the income support side, we've created, or almost created, 3 apps. An app sort of profiles the income support payment recipients in different areas. Another is looking at time series data of unemployment payment recipients. And another that we're building within DSS as a way to build our own capability, looking at DSS payments by electorate. This is one of those apps. This is the income support data. A little bit of a video here that I'll talk through as it plays. This app allows a user to select an area of interest so they can explore income support population or a specific other payment they're interested in, and compare to local or national data sets that are relevant to the story they're trying to tell. For example, if a user selects job seeker payments, contextual information around employment, industry, or occupation will be displayed alongside those income support statistics. Or if they select disability support payments, they'll see information on disability or long-term health. We're really excited about this as it has a lot of potential offered to combine a range of government and other data. It helps us find insights into geographical disadvantage and helps us decide how to best address community needs in consultation with those communities. Next steps for DSS. So next we're looking at grants data. Grants is another big and broad remit of Department of Social Services. It's not as easy to spatially present as income support. Each program is different, targets a different area, and has a different sort of scale at which it's operating. But going forward, as you move into the grant space, we'll continue to invest resources into the Digital Atlas by selecting and identifying new assets to upload onto the platform, build new apps that inform specific policies or initiatives, improve our own capability to build applications or present data in a spatial way, and collaborate with other agencies and communities to make sure that we're telling the right stories with our data products and tackling the right problems. I'll now hand back to Lisa from Geoscience Australia. Thank you very much.
What you've heard and seen about the Digital Atlas and its capabilities are truly remarkable, and it's the reason I'm here. I love what I do, and I love working with the team that I've got, and they do their job exceptionally well. The Digital Atlas is fostering a growing community of data suppliers and users from across government and increasingly from other sectors as well. Sharing and the integration of data is delivering a whole new level of efficiency for government, enabling access to reliable, meaningful insights in minutes rather than months. And today you've seen just a couple of examples where other departments are using the Digital Atlas to extract greater value from their data, but they're also using it to leverage the capabilities, those geospatial capabilities already there to enable better place-based decisions. It means that they don't have to invest in building or augmenting their own geospatial capability. They can invest that in their own data specific to them, and they can integrate with other data custodians who have national trusted quality data. So before I go to the Q&A, and I do know that we've got a few questions in the Q&A tab, I just wanted to quickly go through just a couple of different ways that you can use the Digital Atlas of Australia. So as I mentioned here, the Digital Atlas can be connected into other systems and other technologies, and there's a few different ways that you can do this. What you can see in front of you is that you can download the data in a number of different formats. And for large data sets, you can use a filter option to identify a specific geographic location or data attribution to limit the size of the data sets. You can also connect to an API, a live stream of the data from the Digital Atlas to your chosen system or technology. And what you can see on the screen is an example of connecting one of our APIs into the Victorian Digital Twin. And you can connect the digital API into software like Power BI or generative AI programs. And really what we're looking to do is avoid duplication of effort. In a zero-sum resourcing game, there is no room to be doing multiple things multiple times. We really need to be able to share the highest quality trusted information that we possibly can. And the Digital Atlas is that integrated geospatial capability that allows us to share and integrate our data. Moving along here, we can see there's a whole range of different spatial themes, and we also have the ability to create a map. And we can do that either as a basic or advanced. And we have an application here to help people who might not necessarily be geospatial professionals, but want to build their own map. So we've added help instructions to create a map application to walk you through the different tools available. And in the example, you can see how we're using the basic map function to explore vegetation data from the Department of Climate Change, Energy, the Environment and Water at a specific location. And that we also have a series of buttons available to change the visibility of layers. And we also have a slider that you're going to see in just a wee moment. I'm speaking too fast, clearly. There we go, there's a slider. So we can function to see the data in comparison with other sources. And this is all built-in functionality that you can access through a series of applications as the easiest way for you to access this functionality. And this is available Digital Atlas Australia for everyone. You don't have to be in the government to be able to do that. We've got some recent releases. As I noted on previous slides, we've got 173 data sets sitting in there. What I did fail to mention, I guess, is really it's a buy once, use many. So we're looking to making that data as available as possible to as many users as possible. In the Digital Atlas for Public, then we have everything is available under a CC BY license, so you can use it for almost anything that you can possibly want to. And it's also about the amalgamation of a series of data sets as well. And a couple of examples is the National Bushfire. I'm going to get the acronym wrong, aren't I? The NBIC datasets is the first national standard view of near real-time and historic bushfire boundaries. And I know that in AFAC last week, there was a bit of a showcase on this. And you now have bushfire data there from 15 minutes ago, and you also have all the way back to 1899 if the data exists, which is pretty amazing with some detailed maps and apps. But we continue to release, long story short, we continue to release data. We only went live on the Digital Atlas 2.5 months ago, and we're in beta a year before that. And we continue to iterate in our data sets. And here is some of the most recent. And I'm just going to have a quick look at the historical aerial photography application, which was just released a couple of weeks ago. So this application allows you to search, view, and download over 800,000 aerial images by location what is going on there? By location dating back to the 1920s, and we're continuing to work with the National Archives of Australia to digitise the remaining 400,000 images and make them available in the app. The exciting thing is not only can we just access them, but we can also integrate them with other data sitting in the digital atlas. And it's also proven that being able to incorporate this application in the digital atlas, then it is making imagery that in some instances has been a while for available for a number of years, far more findable and accessible. All right, so just talking about some of the data coming soon. So Forests of Australia and Natural Resource Management from DAF. We've got grants information working collaboratively with our colleagues at Department of Social Services. We've got some Earth observation data working internally in Geoscience Australia with the Digital Earth Australia program and looking to bring in some of their product. And we're also looking at being able to incorporate the mineral potential data and an interactive map from Geoscience Australia. And excitingly, I get to show you a teeny tiny preview about what that, this is not live, but what the mineral potential application may look like in the future. And this is a preview, it is not live, and it's just about how we can incorporate different data sets to be able to improve data-driven place-based decision-making. And in this application, we're showing 9 data sets highlighting mineral potential across Australia. And users can scroll through layers showing different minerals using the information panel, which updates with summaries and links to detailed information. And in the future, we'll be able to switch layers on and off, customize view, explore in-depth insights, and importantly, fuse it with a whole range of other information such as socio-economic information, critical infrastructure, biodiversity information, whatever we've got in the digital atlas and is important for place-based decision-making around mineral potential, and we'll build it into an application. So early days at the moment, but looking very promising in the not too distant future. All right, I'm getting to the end of the presentation. I think we're going to go to some questions and answers, but in the interim, if you haven't had a look at the Digital Atlas, I highly encourage you to get in there and have a bit of a play. You can also subscribe for updates. So if you want to know what data set or what application is being dropped as soon as it is being dropped, then just subscribe. And also if you've got any questions, then just reach out to the team through the information available at the Digital Atlas website, and we'd be more than happy to have a conversation about how you can use Digital Atlas Australia to underpin place-based decision making, whether you're in multiple levels of government, industry, community, academia, you name it. I'm sure Digital Atlases can value add somewhere in how you do business.